Our I can statement for today is E7. I can compare problem-solving methods with or without an equation. In this lesson, we're going to take what we've been doing in our current unit equations, and we're going to compare it with arithmetic or more traditional solution methods, and we're just going to do a quick compare and contrast. All right, our first story problem. A zoo pass for the day costs $30 and includes $14 in admission plus 3 passes, one for the train, one for the sea lion show, and one for the dinosaur exhibit. Each pass has the same value. How much does each pass cost? So the first thing we're going to do is solve this algebraically. Okay, now that's using algebra. This is going to be our standard equation-based solution method. So the first thing you want to do is write an equation. Now I know the total is going to be $30, and then I know that my constant amount is that $14. Okay, the reason for that is because my variable is going to be how much each pass costs. So I could use P for my variable. And 14 doesn't tell me anything about the passes, the number of passes, the cost of the passes. It's just that separate admission cost. The number that does relate to the pass, the amount that depends on the variable, is the fact that there are 3 passes that are included. So I'm going to write 3P as my amount that depends on the variable. So this is my original equation. 3 times the cost of 1 pass plus 14 equals 30. Now I'm going to solve my equation. So I'm going to subtract 14 from both sides. So I get 3P equals 16. Then I'm going to divide both sides by 3. Okay, so my first step was to write the equation. My second step was to subtract 14 from both sides. My third step is to divide both sides by 3. So I get for my answer P equals 5.3 repeated. Now, the question's asking how much does each pass cost? So with dollars, I want to write my answer to the nearest hundredth place. So I'm going to say that each pass costs about $5.33. Now let's take a look at the arithmetic way of solving this problem. Now, arithmetic should remind you of arithmetic. That's what they used to call our traditional operations: add, subtract, multiply, and divide. So what I'm going to do is I'm just going to document the step-by-step process I would use to solve this without an equation. I'm going to start with the $30 of total cost, and I'm going to subtract the admission cost because I know that that has nothing to do with the cost of each pass. So 30 minus 14 is going to give me 16. My second step, I know that $16 is the cost for the 3 passes, so I want to divide it by 3 to figure out the cost of each pass. Okay, so that gives me 5.3 repeated, or $5.33. So let's take a moment while we're on this screen to kind of look at the similarities and differences. So on the equation side, there's certainly a lot more writing. Okay. On the arithmetic side, it seems to be less writing, but they both have the same steps. Notice that for both, we subtracted 14 from 30, and we took 16 divided by 3. Both steps were included in both methods, and then we got the same final answers. Okay, we got the same unrounded, and we got the same rounded answer. So there's actually lots of similarities between the two methods. So let's record those similarities and differences in these boxes. So similarities, I could write that they both subtract 14 as the first step, and then divide by 3 as the next step. And as another similarity, they both have the same answer, which is good. For differences, I could write, for example, the equation method has an extra step, writing the equation, but we can also use the equation to check our answer easily. We plug our answer into the original equation to check. So that was one of the differences that I noted. This box I want you to fill in, and there's no one right answer. I want you to discuss which method you prefer and why. Be sure to include the why piece. And saying, I like this one because, or because I do, is not a valid piece of evidence. So give me a reason why you prefer the method that you do for this particular problem. All right, let's take a look at our next problem. A salesperson is paid $50 base pay per week and $3 commission per sale. If she needs to make $100 this week, how many sales must she make? This is a great opportunity to practice writing an equation from a story problem. So before I continue on, I want you to see if you can write an equation on your own. And you can do that in this first box here. Write an equation on your own. So pause the video now if you'd like to try writing it on your own. This time, instead of starting with our equation method, what we've been used to, let's solve this arithmetically. I'm going to start with the total amount I need to make this week, which was $100. And if I'm figuring out how many sales she wants to make, I want to get rid of anything that isn't related to sales. So I'm going to subtract that $50 of base pay. That's the amount she's going to make no matter how many sales she does. Okay, so 100 minus 50 gives us 50. The next thing I'm going to do is I'm going to figure out, well, if I need to make $50 in sales and I make $3 per sale, how many sales do I need to make? So 50 total dollars divided by $3 per sale is going to give me 16.67, or 6 repeated. Okay, now, is it possible to make 16.66666666 sales? No, we need to round, and we want to round to the nearest whole number. Okay, and in this case, that's going to be 17. Now let's do a quick check. Type into your calculator. 17 times 3, that's 51, which is bigger than the number 50 that we need to make. Now, if you tried 16 times 3, that gives you 48, which is not enough. So that's why 17 sales is our answer. Now let's try it algebraically. Okay, so let's do our equation. Well, our total is 100. The amount that stays the same, our constant, is that base pay of $50 per week. And then our variable is the number of sales. I'm going to use X to represent the number of sales. And I'm going to multiply that by 3 because I make $3 per sale. So this is my equation. Those of you that tried it on your own, how'd you do? If you made any mistakes, go ahead and fix those now. Our next step is to solve our equation. So I'm going to draw a line down. I'm going to subtract 50 from both sides. So my 50 cancels out. So on the one side, I'm left with 3x. On the other side, I'm left with 50. And then I want to divide both sides by 3. So the 3 cancels out, and I get x equals 16.6 repeated, which we know we need to round to 17 sales from our previous example. Okay, so let's compare. We are starting with 100 and subtracting 50 in both examples. Then we're taking 50 and dividing it by 3 in both examples, and we end up with the same final answers. Go ahead and fill in this box on your own. Please list the similarities just like we did with problem number 1. List any differences like we did with problem number 1, and feel free to add your own similarities and differences as well. And then once again, which method do you prefer and why? You can look back to what you wrote in the previous examples boxes, but I do want you to write similarities, differences, which method you prefer and why. So it's not okay to just write same as last one on your problem. Okay, I want you to see if you can figure out an equation for this one as I'm going through. MacDonald had a farm with a certain number of orange trees. He had to cut down 5 trees to control the insects. Each of the remaining trees produced 21 oranges this week, producing a total harvest of 4,179 oranges. How many trees did MacDonald's farm have initially? So this question here, how many trees did we start with? That's going to be our variable. So I'm going to use T to represent our starting number of trees. Now I'm going to do this one a little bit differently. Okay? We know that the total needs to be 4,179 oranges. Okay? But this time I'm going to follow the story. I started with T initial trees. But then we cut down 5 trees. So the expression T minus 5 represents the number of trees that we currently have in the farm. These current trees produced 21 oranges for each tree. So I'm going to take the number of trees we currently have and multiply it by 21. This is the equation I'm going to use to solve this problem. Okay? Now, if I'm doing this arithmetically, I would start with 4,179 and I divide it by 21 to get the number of trees we currently have. And I would get 199 trees. Then I'm going to add 5 to that to get the number of trees we started out with. And that number is 204 trees. So, even though we've learned when we see equations that look like this, we can use the distributive property, 21 times t plus 21 times negative 5. Another method would be to divide both sides by 21, because when we have a factor of 21 on the top and the bottom, they cancel out to make 1. So I'm left with one group of t minus 5, and that equals 199. Then I can add 5 to both sides to get t equals 204. So notice, even though I wrote an equation, I can use my arithmetic solution method to help me to see new ways or different ways or simpler ways of solving my given equation. So if you struggle with writing and solving an equation, you can use the steps you would use to solve it arithmetically to help you write and solve the equation. Go ahead and fill in the boxes for similarities, differences, and your preferred method. And then we'll look at our last example. Okay, John and his friend have $20 to go to the movies. Tickets are $6.50 each. How much will they have left for candy? So if I'm solving this arithmetically, I have John and his friend that have $20, and they're going to buy 2 movie tickets. So I could do 20 subtract 650, subtract another 650. Or I could do 650 times 2. Sorry, that's supposed to be 650. 650 times 2, which would be $13. And I could write another expression, 20 minus $13. Okay, that's the amount that it's going to cost to pay for both tickets. The question is, how much will they have left for candy? Well, 20 minus 13 is going to give me $7. Now let's look at this algebraically. My total is 20. I have two tickets that I'm buying times $6.50 each, plus the amount I spent on candy. Well, 2 times $6.50 is 13, so we could also write this as 13 plus C equals 20. And then I'm going to subtract 13 from both sides to get C equals 7. So we can see similarities and differences in both solution method. Go ahead and fill in the similarities, differences, and your preferred method boxes for this problem. And that's the end of our examples for today. You can watch them as many times as you need to make sense of how we solved both arithmetically and algebraically. And you can use these story problems to help you practice writing equations. Thanks for watching.